it's another day and we're back at IAGS and I'm very excited. I've got Nick Oliver with me. Thanks for chatting to me, Nick.
Hi, Jess. Nice to chat with you.
It's going to be good. So how are you finding the week so far?
Good.
Yes.
Good. It's actually quite nice having a day off in the middle, isn't it?
I know, the field trips, everyone seemed like they're having an awesome time yesterday. What did you get up to?
I worked on my next talk for next week in Perth
my
hotel room.
I treated myself. I went and saw Harndorf, which was like the cutest.
Isn't it a weird place?
Sweet little,
it's
sweet
funny,
town.
Isn't it? Yeah, I haven't been for a while, but it's a great spot.
Yeah, it was really fun, that one. So, but no, it was nice to have a little treat midweek. But yeah, what brought you to IAGS this week anyway?
Well, yeah, since COVID, I haven't been to. I used to be a conference junkie, particularly as an academic.
Yeah.
And of course, COVID put paid to all of that. So I've only been to one conference in the last 5 years. So I thought it was about time. And I went to the IAGS in Rotorua, I think, about 10 years ago, and that was fun.
Yeah.
And it's a good size. I mean, it's a good number of people, and you know, I'm half a geochemist anyway, so it's always good to catch up.
Yeah. So what does half a geochem mean? How do you half get into it?
Look, everybody knows that I'm not really a geochemist. I mean, I do structural geology as much as I do geochemistry, and so that fusion has always been my forte, I guess.
Yeah.
Because there's not too many people cross over between those two. It's like there's structural geologists and there's geochemists.
Yep.
So it's kind of fun being in the middle.
Yeah.
And I've kind of always done that. So
that's really cool. What are some of the having such a different perspective, I guess, than like the standard, structural geo or standard geochem? Like, what sort of things do you really like focusing on?
Yeah, no, like it kind of means that, you know, if you're faced with a complex fault system, for example, you can look at that in a structural way, and you can look at it a geochemical way.
Yeah.
And these days with the new software now, it's quite easy to fuse the geochemical data with the structural data, which people are not really used to doing. It's not a traditional field.
Yeah.
And that kind of means you get a lot more out of trying to understand mineral deposits and their surrounds.
Yeah.
So that sort of data fusion thing is something I've been involved with a fair time.
Yeah, that's really cool. I like that. And we were having a really cool chat the other day, sort of about university and the future of geoscience and geochemistry and bringing that talent into the industry. And then the flow-on effects, like you were even having a really good point earlier of sort of like, technology is providing all these great insights, but when you've got a lack of geochemists available and things like that, sort of like some bottlenecks going on. But I was really keen, like all your history with JCU and all your, your background. I wanted to really have a chat with you, what you're thinking with it.
Yeah, we're in an interesting space at the moment because, of course, the commodity prices go up and down and the exploration expenditure goes up and down.
Yeah.
But in Australia for the last 20 or 30 years, the number of geologists and geochemists entering the workforce has pretty well systematically been dropping. And there's some unis that are still doing okay, Curtin, Monash, UWA, to name a few, Adelaide. But when I went through as an undergraduate, there's maybe 25 thriving departments around the country, and now there's like, I don't want to insult anybody by saying that their department's not thriving, but really there's only been a few that have really ridden the wave.
Yep.
And just most of them have been submerged. So JCU's only a fragment of what it was previously. Macquarie's closed, et cetera, et cetera. And so it's a real problem now, right on the cusp of this sort of critical minerals boom, that we're not really educating the next generation of people as fast as we should be doing. And the standards have been dropping as well because there's less money in the system, field trips getting cut, so people looking at rocks less, which is a big mistake. And the question is what to do about it. It's not obvious because it doesn't matter which side of politics, they really haven't been paying attention for the last 20 or 30 years. And other countries are doing a much better job. I think that's the sad thing, is I think we've kind of dropped the bundle in the university sector in general in this country. I think we're not doing particularly well in that regard.
Yeah. So. I know it's a shame to sort of see it going in such a downward trend when we're such a lucky region with like all the resources that we have.
Yeah.
Big.
Look, I won't say I've given up on the university sector because obviously there's a whole cohort of very hardworking academics out there doing the stuff. But I think Australia's now got to the point where there's a couple of things we don't do that happen in other countries. And so, for example, if you look at Canada and US, there's massive endowment funds that are coming from industry. And I think Australia is probably overdue for trying to develop a bit more specific direct support from industry into minerals.
Yep.
So for example, if we look at Codes, University of Tasmania, for a very, very long time, the stronghold of economic geology in this country. And they're kind of, in trouble at the moment because of the university politics, whereas MDRU at UBC, for example, they've got this huge endowment funding behind them with lots of companies and lots of former graduates that chip in quite a lot of dough into that program to keep it afloat. And I think Australia kind of needs to move in that direction. I can't really think of any other, apart from like having a federal government review, which would defeat the purpose, a review of the university sector in Australia, like a big Inquisition type review. But even that's not likely to come up with a change. I think mentally we're in a bit of a difficult space with this. It's not encouraging. I'd like to be more positive about it, but the only really way I can see it is to try and get money outside of the university sector into the university sector.
Yeah. Yeah. Do you think it's something that industry should be responsible for? Or
I don't need. They don't need to be solely responsible for, because of course industry puts a huge amount of support into our sector around this country. I think it just needs to be more formalised and structured in a way that gives minerals departments, geology departments, engineering departments a little bit more. A bit more to lean on when times get tough, so that they can dig into those endowment funds when they really need to and use them to build things up when they need to. And look, we've got the capacity, obviously, in this country with some very, very big mining houses based in Australia, and I think they don't need to be responsible, but I think we need a system now that tries to develop that and move it forward. There's no sort of obvious, easy way to do that apart from knocking on people's doors and sort of saying, well, what about it? So
yeah, it's a tough one, isn't it?
Yeah, and there's things like, maybe we can do it by formalising placements in third year and fourth year uni, like engineers to some extent do. You formalise placements so that geology or mineral students go in with company sponsorship into a company environment. They get university course credits for that and also get an exposure to the industry, that sort of stuff. But that's probably just one example of many things that need to happen, I think.
Yeah. And so for, say, like geochemistry specifically, what are you seeing in the trends there? Like, is it something we're trying to encourage other earth science disciplines into geochem, or, curious where the geochem side sits.
Geochemistry is certainly thriving at the moment, and that's partly a consequence. I don't want to name particular individual friends, but I think IMDEX and IAGS have really, that piece of software has really changed geochemistry in the last 10 years, and it's such a good piece of software that it actually encourages people to use it, and that's actually meant that it's much easier now for people mentally to get a hold of what the geochemistry can do, because that's such a good piece of software.
Yeah.
But in general, I think the role of geochemistry is expanding quite rapidly, as we've heard from a few of the talks this week, because it's getting into the geo-environmental, geo-botanical, and a lot in tailings processing and waste recycling. And we heard the talk this morning from Kathy Ehrig about the details of the wealth of the geochemistry and some of our big mineral deposits. So there's a lot of excitement still, and there's a lot of new techniques coming available for people to access different parts of geochemistry that they didn't have access to before. But that in itself creates a bit of a problem, because there's now so much data, so many new techniques. The challenge now is to actually work out to ask the right question about what is needed, and the tendency has just been to grab new data and play with new devices without really thinking through exactly how they're going to be used right through the workflow or the life of a mine or an exploration program.
Yeah. What are some of your best tips for getting maximum utilization out of it?
Consistent data sets, and that's what I talked about the other day. It's so common to because that's the problem. You get new gear, and so you want to use the new gear, but it produces a new data set. That new data set's got to be matched with the old data sets, and it's not that the new data set's necessarily going to be better. It's often going to be at a different scale or with different detection limits, or fundamentally different with the way it works. And so there's this, every time you gather this new data set, then you're not just gathering new data, you're gathering a whole problem associated with how you're going to fuse that new data with the old data.
Yeah.
And look, as I get older, it's easier to say that, because old people would typically say what I'm saying. But it really is a problem, because it's the whole world, really. We've got so much access to so much more information now.
Yeah.
people just in general don't know what to do with all that information.
Yeah.
And so people are not thinking through problems in the way that they used to. The problem solving now is more data filtering, whereas previously, you know, when you've got less data, you kind of think a problem right through and say, well, this is the tool I want to use for that. I'm going to think it right through. Whereas now it's like you've got all of this choice and all of this data, and 50% or more of the problem is actually working out how to approach it, because you've got so much access to so much more data.
Yeah.
And that really is the big challenge.
Yeah, definitely. No, there's been some really interesting conversations coming out this week. And I think, having weeks like this is good, getting everyone together to sort of really, hash out some of this stuff. But on a bit of a lighter note, I have been having a lot of fun testing everybody this week.
Here we go. So I told you, I'm only half a geochemist, so I'm only going to answer questions for half the periodic table.
The first half or the second half? Do you have a preference?
No, the first half's easier than the second half, that's for sure. Especially the ones that are generated by nuclear fusion and fission. So I can't answer any of those.
How do I know what that is?
Or the ones on the second bottom row. So I don't know that one much. I'll show you.
I know which ones.
Yeah, all these ones here. These are kind of.
No, so the bottom,
the bottom row, the fission and fusion ones. All of these grey ones here, they're kind of, they're real, but they're kind of, you only get them from nuclear fission. I think most of them. Right.
Well, how about 88?
I don't know what 88 is. No, I'm not that good at geochemist. Would you mean mass or number? Haha, there's a question for you.
It's not in brackets. That's mass, isn't it?
Can we look?
Now you're looking at the answer.
Yeah, the mass is the one with the decimal places, and the one on the right's the number.
Yes.
Yeah, I don't know what 88 is.
Radium.
Yeah, radium. I did use that in hot tubs and salt baths. Why would I know about that? You should know about radium.
Should I?
Well, have you ever been in a hot tub?
I do love them, yes.
Well, there's probably radium salt. I think that's radium. Radium salts.
Oh.
I think. It's like some of the stuff you stick in your bath to make you feel
I thought they were like
special.
Magnesium salt.
Yeah, but it's magnesium. I think radium.
Is that the same?
I don't have to check that.
What about 25?
25. I should know 25. That's the number, not the mass. 25.
The number, yes.
Oh, give me a choice of 3 that are nearby.
Nearby. Iron is a neighbour.
Yeah, that's not iron. No, it's not iron. So 25. That's not. No, I don't know.
Manganese.
Okay.
Yep.
Yeah.
There we go. Well, it is a tough one. So, yeah. I think that's all I've got for you.
No, I failed. I don't care.
I don't think anyone has done particularly great this week.
Who cares what the numbers are? I mean, I can see the periodic table. I can look up the numbers.
I know exactly.
Talk about extra information. I don't need that information in my head.
What fun facts could you give me about any of them? Take your pick. A fun fact. What about magnesium? Let's do that.
Fun
Number
fact about
12.
magnesium. Okay, so you can use it in bath salts along with radon. And you get it in seafloor. You get a magnesium enrichment in seafloor alteration around black smokers.
Right.
There you go.
There you go. Okay. Well, this has been awesome. It's been such a pleasure catching up with you. Thank you for sitting down with me today.
Thanks, Jess.
And I'll see you soon.
Yeah, nice to be here.
Thank you.
Great. See ya.